Thank you for coming and tuning to my channel this morning. I ask you to subscribe to this channel. Now, today's lesson is about common probability terms. What are these common terms often used in probability theory? The first one that we want to look at is called the sample space. Now, a sample space is basically a set of all possible outcomes of an experiment or a trial. Usually a sample space is denoted by S or this sign you're seeing here, omega. Now, a sample space is the number of the elements in the set S. So if say you're tossing a coin, then we expect that the trial or the experiment is a fair trial, then you expect that it will come out as a head or a tail. So that therefore H and T constitute sample space. If you have got a coin and you're tossing 3 times, then we expect the sample space to have all the possible outcomes of this toss. So if I tossed the first time and the outcome was a head, and I tossed the second time and the outcome is a head, and I toss the third time and the outcome is a head, then this outcome will be given by HHH. And because there are so many possible outcomes in this fair trial, then the total sample space would be given by all this that you're seeing. So either head, 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 tail, head, tail, head, and so forth until tail, tail, tail. Again, in throwing of a die, the possible outcomes are a die has 6 sides. So you have got 1 appearing on top or 2 appearing on top or like that until the last one. And so the second term that we want to look at is what is an outcome. An outcome is basically all possible results of an experiment. Each possible outcome of a particular experiment is unique, and different outcomes are mutually exclusive. In other words, only one outcome will occur. The outcome of one prevents the outcome of the other one. The third term that I would want us to look at now, under sample space, we could also look at 2 types of sample space. First one is discrete sample space. So a discrete sample space is one that is listable. It can either be finite or infinite. So you have an outcome of, say, a head or a tail. If you are tossing a die, the outcome may be 1 on top, or it may face 2 may face on top, or 3 may face at the top, and you can have as many other outcomes of an experiment. Now, all these are kinds of forms of a discrete sample space. Now, notice that this sample space is either finite, in other words, we can count. So you have got a sample space of either head or tail, so we can count. Or if it is tossing of a die, you have either 1, 2, 3, 4, 5, 6. That is countable. But you can also have a sample space that is uncountable or infinite. So in which case you have got 1, 2, 3, dot, 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 or 13, 17, and the number continues. Now, for a continuous sample space, then we're looking at possible continuously distributed outcomes, in which case we are saying the probability will range between 0 and 1. So if I'm tossing a coin, the outcome is either a head or a tail. If the outcomes are equally likely, then we say that the probability is a half for either head or tail. But sometimes you have an experiment that has quite a number of so many possible outcomes, in which case the values of the probability will be either too small or too big, but of course ranging between 0 and 1. So the range may be 0.01, 0.9, 0.8, 0.4, and so forth. Now, what is an experiment? The third term is we're looking at an experiment. It is basically a repeated procedure with the well-labeled, defined possible outcomes, or the method by which an observation or a measurement is obtained. So I have an experiment, for example, tossing of a coin, or an experiment of rolling a die, or measuring the temperature of the day, whether the highest and the lowest temperature in a month, or you want to record the effectiveness of a certain drug, or you want to look at you're doing an experiment and giving the weight of the children being born in a dispensary, for example. That can be a form of an experiment. What is an event? An event is a collection of outcomes. It's a collection of outcomes. It is a subset of the sample space. Now, out of the total results obtained from a certain experiment, the set of those results which are in favor of a definite result is called the event and is usually denoted by E. Now, if A is the probability of tossing a coin 3 times, then the sample space, as we saw earlier, would be this. Now, I would want to get a specific event, say having exactly 2 heads. I'm looking for an event if I have tossed a coin 3 times. I'm looking for an event that will give me exactly 2 heads. Now, if I would look for exactly 2 heads, then I'll look at all these possible outcomes and look for where we have got 2 heads. For example, here we have got head, 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 tail, head, and then tail, head, head. As you can see, the total sample space was 1, 2, 3, 4, 5, 6, 7, 8. And now, if I'm looking for a specific event where I need the outcome as exactly 2 heads, then I would look for these values. So it will be H, HT, HTH, and THH. And so, as you can see, sorry, the diagram is too slow, cannot show the lower end, but exactly that is what we're talking about. Now, events are equally likely, or they can be exhaustive events. Now, what do we mean by equally likely events? When there is no reason to expect the happening of one event in preference to the other, then the events are equally likely. In other words, we are saying that every outcome has an equal opportunity. If you're tossing a coin, then you expect, if it is not biased, then you will either get a head or a tail. In which case we are saying you are equally likely to get a head or a tail. What are exhaustive events? Exhaustive events means that all possible outcomes of an experiment are known. So if I'm tossing a coin, for example, I'm sorry, I'm using this too much, then the possible outcome of tossing one coin, possible outcomes is either head or tail. But if I'm tossing 2 coins, 2 separate coins, then I should be able also to get that likelihood of those events. So the total possible outcomes is what we are saying the exhaustive events. Now, in tossing, for example, a die, there are only 6 exhaustive events, as we have seen. It's either the faces, the one is facing on top, or 2, or 3, or 4, 5, or 6. Now, there are also types of events. Sometimes we have a simple event, in which case we are saying that it only has a single outcome. So if I'm tossing, the probability of tossing a coin, if A is tossing a coin, then the outcome may be a tail, or the outcome may be a head. If I have a compound event, then we are saying that it has multiple outcomes. So I'm tossing 3 coins simultaneously. Then you expect probably the outcome to have multiple outcomes. These are multiple events. So if you're tossing 3 coins simultaneously. What is a mutually exclusive event? Now, let me assume that you're running. Is it possible that you can run backwards and forwards at the same time? Or is it possible that you can be alive and dead at the same time? Or is it possible that you can be married and unmarried at the same time? Is it possible that you can be sitting or standing at the same time? Now, this is not possible. Now, such events, we refer to them as mutually exclusive events. Now, mutually exclusive events are events that cannot occur at the same time. In other words, the occurrence of one prevents the occurrence of the other one. In other words, we are saying that it is disjoint. If 2 events are mutually exclusive, then the probability of either occurring is the sum of probabilities of each occurring. We'll look at that in our next clip. Now, we can also define mutually exclusive events as if 2 events A and B are mutually exclusive, then the sample space S is said to be mutually exclusive if the intersection of A and B is null. In other words, that event A and B do not have any elements in common. We'll look at that in our next clip. What is a dependent event? A dependent event is one in which the probability of an event happening affects the probability of another event happening. For example, if one is stealing, there's a relationship between being jailed or not being jailed. Or if you're paying for an exam, if you're a student, then you're likely to sit for that exam. If you have not paid rent, you're likely to be evicted out of the house. If you have got an academic discipline, you're likely to pass an exam. So we're saying that one outcome leads to the outcome of the other. So 2 events are dependent if the outcome of the first event affects the outcome of the second event, so that the probability is changed or is affected. In other words, we are saying 2 events are considered dependent if the occurrence or the outcome of the first event changes the probability of the next event occurring. As I've said, if you steal, you're likely to be jailed. The probability of being jailed is high. So stealing and being jailed are dependent if a law has to be obeyed. Now, I've got an example of a dependent variable, a dependent event. We're going to look at that later. Now, what are independent events? Independent events. Let me look at an example. If I'm tossing a coin, and then I'm tossing another coin later. So So if I toss a coin and the outcome is a head, and I toss a second coin and the outcome is a tail, can we say that the outcomes are related? Definitely not. The outcome of the first experiment or trial does not influence the outcome of the second trial. So if I'm tossing two coins independently, their outcome cannot affect each other. Or for example, today, if it is going to rain, is it likely to affect my likelihood of making a call to a friend? It's not. It's not going to. So in which case we are saying that independent events, two events are independent if the probability of one event occurs on any given trial of an experiment is not affected or changed by the occurrence of the other. How? What do I mean? An independent event is one in which the probability of an event happening does not affect the probability of another event happening. So, raining today and making a call are not related. Or throwing a die and the outcome of a throw of a coin or tossing of a coin, the outcome are not related. So mathematically speaking, we're saying an event A is said to be independent of another event B if the probability of occurrence of one of them is not affected by the occurrence of the other. Look at probability function later. Then lastly, let me look at the properties of probability. Now, we know very well that probability of a function A is a number that ranges between 0 and 1. In other words, 0 for absolute impossibility or uncertainty, and 1 for absolute certainty. If you're so sure something is going to happen, then the probability is 1. If you're not so sure, if you are very sure it's not going to happen, then the probability is 0. But then probability may range between 0 and 1. First property. Second property is that the total sample space of a probability function is equal to 1. So if I wanted to find out how many students are likely to pass, male, female, then I should get the total probability of male passing, then total probability of female passing, and the ones who may also not pass. So if I get all those probabilities, then that should be equal to 1. In simple terms, we are saying if I'm tossing a coin and the outcome is a head, which is equal to a half, and I'm tossing or I get a tail, then we are saying that the probability of the head plus the probability of the tail is supposed to be equal to 1. Then lastly, properties. The probability of a union of a disjoint set independent is equal to the sum of probabilities of these events. In other words, we are saying that if you're getting the probability of A union B, given that A and B are independent, then the probability of A union B will be the probability of A plus the probability of B. This is where we stop today, and we hope to get feedback from you. Thank you so much.